Hello friends, this video on structure of atoms part 1 is brought to you by examfear.com. No more fear from exam. In this chapter, we'll study about the structure of atom. So the question that comes to our mind is, what is atom? In fact, we have studied this in the last chapter. Atom is nothing but the basic unit of matter. It is the basic unit of matter. Please let me reiterate. Any matter consists of this atom. So atom is a basic unit of matter, and it is nothing but a dense central nucleus surrounded by negatively charged electrons. So it has dense nucleus and electrons. You see, this is how actual atom looks like. The red one which you see here is the dense nucleus, and the gray, the black and the light black grayish color, this is the area where electron exists. Electron moves around at a very high speed. This is a cloud of electron, actually a cloud of negatively charged electron with a dense nucleus. If you see, the nucleus occupies such a small position or small space, and the cloud occupies most of the space. This is atom. And in the nucleus itself, we have again protons, neutrons, and this is electron. That is something we'll study in this chapter. This is proton, neutron. So atom has proton, neutrons, and electrons. Electrons are negatively charged. Proton, P is positive charge, and neutron, as you see, neutron is neutral, no charge. So we'll study about this in this chapter in detail. Okay. So if you assume cricket ball represents the nucleus, if this is the nucleus and this is a cricket ball, then this whole length is almost 5 kilometers. This is just to give you an idea on how small the nucleus is. This is a cricket ball, and this length is almost 5 kilometers. So that is the range we are talking about, right? Think that if you see the atoms, they are different. Atom of a sodium, atom of chlorine, atom of carbon, they are all different. The question is, what makes them different? Because what I have told is, atom is nothing but there is a nucleus, and then there is a electron cloud. If that is atom, what makes the atom of one element different from another? So the question is, what makes them different? That means there has to be some difference. Maybe the number of electrons, the number of protons in the nucleus, there has to be some difference between these atoms, right? Because they are different, and in all these we have a nucleus, we have electron, we have nucleus, we have electron, we have nucleus, we have electron. Maybe in this we have 4 electrons, in this we have 5 electrons, maybe in this we have 2 electrons. So the electron counts matters, and that is what differentiates these atoms. So we'll study about these in this chapter, right? And as Dalton proposed that the atom is indivisible, that is, you actually can't break the atom. The question is it true or is it false? Actually, it is false. You can actually break the atoms into electrons, protons, and neutrons. So we'll study about these as well. Also, if you have noticed, or if you can do this experiment in the lab, if you take a metal and you try to create this circuit, and when you heat it, you'll see that more current flows. You can put some meter here to read the amount of current flowing. So the metal conductivity actually varies with temperature change. It generally increases with temperature change. The question is why it is happening, right? So these questions can be answered if you know the structure of the atom, because when you talk about the metal conductivity, the metal electrical conductivity, it is the electron which is responsible for the conductivity of metals. When you heat, when you increase the temperature, these electrons are a little free to move around, and thus the the electrical conductivity increase for a given metal, right? So these questions can be answered if you know the structure of atom. Okay, we know what is atom. Atom is nothing but we have a dense nucleus and then we have electron cloud, negatively charged. Overall, the atom is neutral because the nucleus is positively charged and this electron cloud negatively charged. They balance each other and overall the atom is neutral. If you think, when you rub two objects together, they become electrically charged. Can you think why it is? For example, you take this paper, small papers, and you rub it, and then you take this comb, and then if you see, it will dance like this. Why? Because they become oppositely charged. Where does this charge come from? If you take this towel and a balloon and you rub this balloon, the balloon will get charged, and then if you try to stick this balloon to a wall, you will see that balloon won't fall down because this has got some charge. The question is, where does this charge come from? Because if we assume that the smallest building block is atom and an atom is neutral when I'm rubbing it, from where it is getting charged? That means the atom is made up of something positive and negative charge. And when you rub, somehow this gets break, this is broken and you get charge. That is the only reasoning I could think of here also. If atom is the building block, then from where you are getting charge and atom is neutral. The only possible thinking I could think of is atom itself is made up of positive and negative charge particles. So when you rub, you get charged. That is the only reasoning I could make. Let's study the history of atom. In 500 BC, the Greek and Indian philosophers actually, they have talked about atom. So the Indian philosopher talked about a term called Parmanu, and the Greek philosopher gave this term atom, both meaning the same thing. They told that if you take any matter, you try to cut it, a point will be, you will reach a point where you will not be able to cut it further. So that particular will be called atom. That was their definition. Please note, it was all philosophy. There was no experiments done to prove that. In 1805, John Dalton proposed his atomic theory. We studied about this theory in the last chapter. We'll also touch upon that theory in the next few slides. But this theory could explain a lot of things, law of conservation of mass and other stuff. But it could not explain the concept which we just saw, that is the conductivity of any metal increase with temperature. You have any metal and the conductivity of this metal, this is a metal, increase with temperature. So you increase the temperature, the conductivity will increase. The question is why? How? John Dalton's theory could not explain that. Also, we have seen that when you rub two objects, the charge is induced. That is experimental data. This was also not explained by John Dalton theory. Right? So these two observations made scientists to think why it is behaving like this. John Dalton theory had no answer. He didn't have any answer to these questions. Then 1850, a cathode ray tube was invented by Faraday. This cathode ray tube consists of negatively charged particles, and in the absence of any electric or magnetic field, it traveled in straight line. But in the presence of electrical and magnetic field, the path deviates. The path will, let's suppose, deviate like this. So there are two observations. In the absence of electric field or magnetic field, the path is straight, but in the presence of electric or magnetic field, the path deviates like this. Or it may deviate like this also, depending on the polarity of the magnetic field. Right? So the question was why the path is deviating in the presence of magnetic field. See, magnetic field is charged. Right? So that means these particles which you see in the cathode ray tube is charged particle. Right? That is charged particle. Okay. Also, it was noted that the characteristics of this charged particle does not depend on the nature of gas. You take any gas inside, you take hydrogen, chlorine, doesn't matter. So the particles, their property does not depend on the nature of gas present. So one thing we have told now as per Dalton is, you take any gas, it will have atom, and this atom will have characteristic property. You take another gas, let's suppose this is hydrogen gas, you take chlorine, it will be some other atom, it will have some other property, right? But here what they are saying is, what they have observed is, the nature of these particles is independent of the gas. That means, looks like this atom is actually broken into some particle, and this particle is common in both. Just think. See, till 1805, Dalton has told that every atom, chlorine, fluorine, hydrogen, is unique, right? So atom of hydrogen is unique, atom of chlorine is unique. So if this is atom which we are seeing in cathode ray tube, the property of these particle, if the particle is atom, the property of this particle should vary based on the gas. But the observation was, the property of this particle, the deviation of this particle on the magnetic field is all same. You take any gas, that means this particle is something which is there in all the gas. It is there in hydrogen, it is there in chlorine, it is there in fluorine, right? So what was that particle? So if atom is the last thing which we assume is the building block, and that is unique for all the particles, that means there is something they're missing. There is something which is unique in all the gas. Okay? So this made scientists to think, what is that particle? So by now it was clear that the atom itself is made up of some other particles. Atom is, you can actually break it, because we have told you that conductivity increase with temperature, rubbing two objects induce charge. So let me write here. Conductivity increase with temperature. Number two, when you rub two objects, this gives charge. The second observation. And the third observation is the cathode ray. So all these observations were pointing to the fact that the atom actually is made up of some other charged particles as well. But there was no concrete evidence. At that time, the physics was not advanced, and we didn't have all the hi-fi instruments to actually view the atoms. Now we have. That time it was not there. Right? So in 1886, Goldstein, right? This guy Goldstein, he discovered the presence of new radiation in the gas discharge, and he called them canal rays. Canal rays are positively charged radiation. So this was negatively charged, and this is positive charge. This guy Goldstein was German, and in 1886 he discovered the canal rays, and canal rays are positively charged rays, canal rays. Okay. So that means now we have positively charged rays, we have negatively charged rays as well. So with this, Thomson in 1897, he discovered electrons. See, actually the rays in the cathode ray tube is electrons, but it was not officially or formally named. So in 1897, so we give the credit to J. Thomson for discovering electrons. And since he discovered electrons, and from the past experiments by Faraday and Goldstein, it is proven that we have some positive and negative charge. He proposed a new model. He proposed a model, a watermelon model, a plum cake model, where he told that the whole atom is positively charged and it has negative charged, you can say, the icing on the cake, and overall the cake is neutral. Thus overall the atom is neutral. This was the model proposed by Thomson in 1897, and this is wrong. We'll see that. So this guy DJ Thomson, he could actually find a lot of things. He could find charge to mass ratio. He did a lot of things, but the model which he proposed was wrong. We'll see that, but it was a good start at least. At least this model accepted the fact that the atom is divisible now. You can divide the atom into various particles, positive and negative particles. So this was a good start, good success in the field of chemistry. Nevertheless, the structure was wrong. Right? So by this time, it was actually known that the atom consists of proton and electron. Please note, there is no discussion about neutron till now. So by this time, chemists chemists only, they knew that atom consists of proton and electron. So they proposed various models. Various models were proposed. At this point of time, the physics was not very advanced and high quality instruments were not visible to actually see the atom. It was all guesswork. It was all hypothesis. So what happened in 1909 is a big achievement for the chemist. Rutherford performed a gold foil experiment and he proposed a new atom model. He proposed a model like this, where you have nucleus and then you have electrons somewhere in the space. So he told that most of the space in the atom is vacant and the proton is only in the nucleus. We will understand the Rutherford experiment and we'll understand why he proposed this. He did some experiment and he found that most of the particles actually passed through the gold foil and only few of them reverted back. So with that, he concluded this model. He proposed this model, but this model also had a flaw. The flaw was the question on the stability of the atom, because if that is the case, the electrons will be attracted towards the proton, the nucleus, and it will not be stable. The atom will not be stable. So what happened was the Bohr proposed a new model. It offered a satisfactory response, or it explains the spectra of hydrogen. We'll see what is spectra of hydrogen, but it could not explain the spectra of multi-electron atoms, and also the electron is regarded as a charged particle in case of Bohr model. So Bohr model was a model proposed, but it is also not 100% accurate. And then we had de Broglie came with the hypothesis of dual nature of electrons. We'll not talk about that, but we'll just I'll just help you understand that then de Broglie and Schrödinger came up with some equations, and Heisenberg also proposed some uncertainty principle, and with that a quantum model of atom was proposed, and then Chadwick found neutron. Please note, the neutron was found so late, 1932, very late in the game, because nobody cared about neutron. Neutron is again neutral in charge. Okay, so in this chapter we'll not be discussing much about these. We'll study about this in the higher classes. Just understand that the history goes like this: 500 BC. It's all hypothesis for the atom. Dalton gave theories for atoms, not very accurate. Faraday found cathode ray, the negative charge ray. The Goldstein found positive ray, the canal ray. Then Thomson, he found electrons. First electron was discovered by Thomson in 1897, and he also gave a model which was not correct. Then Rutherford gave a model, then Bohr gave a model, and then finally we got a quantum model which we will study in the higher classes. And then finally, very late in the game, Chadwick found neutrons, and it was neutral in charge. Nobody bothered. Since it is very small, it is very difficult to find. So finally, in 1932, neutron was discovered. Right. So we'll take some question. What is canal ray? So canal rays, we have told, canal ray is also called anode ray. Anode rays, right? And anode means what? Positive rays. So canal ray is also called anode rays. The positive rays is a beam of positive ions created by certain type of gases, not all the gases, and these are called canal rays. And why they are called canal rays? Because they are produced by holes or the channels in the cathode. So if you see the cathode and this cathode, there is a channel here, and this channel, holes in this channel, produce this roll, and that's why it's called canal ray. Right? So lightest one of them is was formed from hydrogen gas, and it is called proton. Okay. The next is, if atom consists of one electron, one proton, will it carry charge? No. Why? Because one electron is one negative charge, right? One proton is one positive charge. So overall it will be neutral. Okay. Thank you. Visit our website examfear.com to watch more and more quality education videos. You can also attempt free online tests that are there in our website. You can also get access to tons of free study materials, and you can also find free tutors and mentors in this website. Thanks a lot for watching.